questions over any of the homework assignments so far? Aiden. Now, what we've been going over lately is congruency shortcuts. And we saw that side, 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 angle, side, angle, side, angle, 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 side, or side, angle, angle are the ones that work every single time without fail. There's not going to be a triangle that's set up in one of these three ways that would not be congruent. Now, the special case one that we had was hypotenuse leg, and this really only works with right triangle. Because if the two triangles are right angles and we have two sides, then it does work. So side, 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 side angle, angle, or hypotenuse leg if they're both right triangles. Now we did have two ways that did not work, and that was
angle, side,
side angle and angle, angle, angle. These are the two ways that didn't work. Now we went over those, and then what we went over yesterday was what? CP. Corresponding parts of congruent triangles are congruent. Now what we're going to be using and doing is taking that and using flowchart thinking or flowchart proofs to show it. And really it's not going to be any different than what we did yesterday. So whenever we look at a proof, we always want to start with the given information. So when we look at this here, we're given that EC is equal to AC. Because that's what they told us first, yes? Okay, so we can start off with that EC. AC, why? Well, it is given, because that's the given information. What else are we told? To AR by given. So we have two sides that are congruent so far. And RC would be congruent to its well, that there is just the same line. Now, what we're doing is we're just trying to prove that angle A and angle E are congruent. Now, since it didn't give us anything about the angles, if we can prove the two triangles are congruent, then we can say the angles are as well. Well, because we get the sides that are congruent in both triangles, well, now we can actually say the triangles are congruent. The triangle CER would be congruent to the triangle CER would be CAR by side, side, side. Since we proved that the two triangles are congruent, their parts would be congruent as well. Their corresponding parts. Well, E and A are corresponding to each other, so we can say angle E is congruent to angle E by what? Well, CP, C. The corresponding parts of congruent triangles are congruent. Because once we're able to say that the two triangles are congruent, their corresponding parts should be congruent as well. And that's what our CP-CTC gives us. Questions on this here? Be ready for the next one. Developing a proof. Complete the flow chart. Provide the missing reasonings or statements in the proof. So they gave us the figure. I drew this figure out for us here so that we can have something to work with and look at. Now, they told us that SE is congruent to SU, angle E is congruent to angle U. We want to show that MS is congruent to OS. So, really we're wanting to say that MS and OS, these two lines here are congruent, is what we're trying to get at. Let's start with the given information. SE is congruent to SU. Well, that's just our given. It was what it's SE and SU. Those two lines are going to be congruent because it told us so. What else did it tell us? Angle E and angle U are congruent. Well, that is just our given information, yes? Okay. So far we have a set of angles that are congruent and a set of sides. Because those two are congruent by vertical angles. Well, do you have enough information to say that the two triangles are congruent? Now, triangle what? SEM. Okay. What? SUO by? What would be our? So we. ASA, yes. You're good. No, that having that point in the dead center, also labeled S, really throws us off. Yeah, because having this additional S in the mix is a little bit confusing, yes? You want me to change that from next year? All right. We can let them deal with it, yes? Y'all had to deal with it, they should too. There's actually a point S in this. It doesn't count for either one, but this S does, not the point. Now, what were we wanting to prove? MS and OS are congruent, and they are corresponding sides. So MS congruent to OS by CP, CT, C. That's it. Questions on this here? Are you ready for the next one? Sunday. I do not know. I just know we play at 4:30. Ground center. So let's look at this one here. We want to show that CL and BM or MB are congruent. That's what we want to say. Now, because we don't have those two lengths, if we can show at least the triangles are congruent, those corresponding parts would be congruent as well. Now, we know that I is the midpoint of C. Well, that is our midpoint of B on our given. Not too bad. Here and there. Any questions on this so far? Yeah. You're good? I can answer it more in depth a little bit later. Now, if I is the midpoint, it means it bisects the length into two congruent segments. So for CM, well, CI is going to be congruent to IM. These are going to be congruent. Well, for BL, it's going to cut it into two congruent segments so that we can say that LI is congruent to IB. Or we can have it flipped and say IL and BI. The order doesn't matter. The reason we knew this is because of the definition of the definition of midpoint told us these. Well, so far, we do have two sets of congruent sides, yes? Now, we wouldn't need to find another set of congruent sides because if we knew that we had three sets of congruent sides, we wouldn't need to do this at all. Because what are we trying to prove? And B, the other set of sides are congruent, yes? So we're looking for a set of congruent angles. Are there any angles that would be congruent? Middle. One. Here. Because since we have two lines that cross, 1 and 2 would be vertical angles, so they are congruent. And it is one of those things that will keep showing up again and again. Any questions on this here? Now we can say what triangle ICLIMB. Because we start at I and went to C and then L, so along the side with 1 and then down. So we would start at I along the side with 1. Now because we're able to say that the two triangles are congruent, the other set of sides, which was CL and MB, we can say that CL is congruent to MB by CP, CT, C. Huh? This here would have been what? Sorry. Side angle side, yes. Thank you. Because we had a side, an angle in the middle, and a side. So it'd be side angle side. Any other questions on this here? Are you ready for the next one? Now, we want to complete this here really to do a proof of the isosceles triangle conjecture. And the isosceles triangle conjecture is really saying if we have an isosceles triangle, the angles opposite the congruent sides are congruent. And that's what we're going to show with this here. Now, they did provide us with a nice little diagram here. And it's kind of telling us any W isosceles. Well, these W, N, and NE would be congruent because it's isosceles. We would have two congruent sides. Now, because by the fact that W is isosceles, we can start off with that. We can really say that WN to EN. And we can really say this is, and here it's given, or really we can say isosceles triangle, definition of isosceles triangle, two congruent sides. Is that S is a median. Now what this means is that NS connects a line from a vertex to the midpoint of the other side. So it's really telling us that point S is the midpoint. And if point S is the midpoint, it's telling us that WS is congruent to ES or SE. Well, this is just definition of median. So we have two sets of congruent sides. We either need a set of congruent angles or a set of congruent sides. We do have a set of congruent sides saying that NS is congruent to NS. It is the same line. So can we say the two triangles are congruent? Mm-hmm. So we can say triangle so WNS is congruent to ENS by side, side, side. Therefore, angle W is congruent to angle E by C. Any questions on any of this here? Y'all need to see another example of one of these. Okay. So this one here is just doing the opposite. And we won't worry about that one there. And your homework is a worksheet.
Nice.
There you go. Give this one to Jordan. Or, I mean, you can pass them all the way back and have Mason pass one over.
All right.
Yes.